Hi guys, I am Dr.S.Nandhabalaji. Today we are discuss about the properties of matter, topics of bending of beams. It's a very important materials of properties of matter. What is bending of beams? An introduction about of bending of beams. Beam bending is a fundamental concept in structural engineering. It involves the analysis and design of beams subjected to transverse loads. Beams are structural elements that are typically eliminated and supported at multiple points. This introduction explores the basic principles and concepts related to bending of beams. Like as fundamental concepts of in bending beams, like as types of beam, loading conditions, and material properties and cross-sectional geometry. Beams can be classified based on their support conditions, such as simply supported cantilever or fixed end beams. Each type exhibits unique deflection and stress patterns. Loading conditions: beams are subjected to various loads including concentrated load, uniformly distributed load, or a combination by both. The type of load significantly influences the beam's response. Material properties: the material properties of the beam, such as its models of elasticity and yield strength, directly impact the beam's bending behavior and its ability to withstand loads. Cross-sectional geometry: the cross-sectional shape and dimensions of the beam significantly influence its bending stiffness and its capacity to resist bending stresses. Stresses and strain in bend beams. In normal stresses developed within the beam due to bending, they are tensile on one side and compressive on the other, with the neutral axis where there is no stress. These stresses are directly proportional to the bending moment and the distance from the neutral axis. And the second one is shear stress. Shear stress arises due to the internal forces that resist the tendency of the beam to shear. These stresses are distributed over the cross section of the beam. Shear stresses are highest near the neutral axis and decrease towards the top and bottom surfaces. Strain is deformation of the beam under bending. It's related to the normal stress through the materials models of elasticity. Strain is highest at the highest point further from the neutral axis and decrease towards the neutral axis. Bending moment and shear force diagrams. Bending moment diagram and shear force diagram, like as a relations of a bending moment diagram, illustrates the distribution and bending moment along the length of the beam. It is essential for understanding the bending stress distribution and identifying critical points. Shear force diagram. Shear force diagram shows the distribution of shear force along length of the beam. It helps in determining the internal shear stresses and identification potential points of failures. Relationships of the bending moment shear force diagrams are related. The slope of the shear force diagram is equal to bending moment, and the area under the bending moment diagram represents the change in shear force. The deflection of beams under bending factor effect on deflection. Load magnitude: higher load leads to greater deflection. Span length: longer span results in larger deflection. Beam stiffness: higher stiffness larger tube leads to smaller deflections. Beam design considerations: strengthen wise the ensuring that the beam can withstand the applied load without exceeding its yield strength or ultimate strength. This involves selecting appropriate materials and cross-sectional dimensions. Stiffness: controlling the deflection of the beam to ensure acceptable performance and prevent excessive deformations. This can be achieved by using stiff materials or increasing the beam's cross-sectional area. Stability: preventing buckling or other form of instability under compression. This involves considering the beam's slenderness and the other material appropriate beams. Factor affecting of beam bending behavior, like as material properties, load distribution, cross-sectional geometry, and temperature variations of the factor affecting materials. Applications of the case study materials of these bending moments like as bridges, building materials and aircraft and vehicles, like as the elasticity modulus. Thank you. Thank you guys.